Good morning. I'm Dr. R.J.Golden Renjith Nimal, Associate Professor, Department of Mechanical Engineering, Bharat Institute of Higher Education and Research. Today, I want to discuss about the manufacturing process. In that, I'm talking about the welding process. There are so many manufacturing processes out there. So in that, the first topic is welding. So what is meant by welding? So the welding is a process of joining similar metals by the application of heat is called welding. So welding can be obtained with or without the application of pressure and with the addition of filler metals, which is known as the electrode. So what is in by electrode? So before that, so during that welding process, the edges of these metal pieces are either melted or brought to the plastic condition. This welding process is used to make a permanent joint, which is obtained by the homogeneous process or homogeneous mixture of two materials. The heat may be developed in several ways of welding operation, and a very good welded joint is as strong as the parent metal. And nowadays, welding finds a very wide applications in almost all the branches of engineering industry. Welding is extensively employed in the fabrication, erection of steel structures in industries, construction fields, etc. And structural joints like bridges, buildings, pipelines, etc. This welding plays a very vital role. And not only that, it plays in the industries like aircraft frames, aircraft structures, and railway wagons, furnitures, automobile bodies, shipbuildings, etc. Depends upon their application, we can use this. Come to the categories or classifications of welding process. It is mainly classified into two types. One is the fusion state welding process, and another one is the plastic welding. Fusion state is otherwise called as liquid state welding process, and the solid state welding process is otherwise called as the plastic welding. So what is meant by fusion welding? Fusion welding or liquid state welding. So in fusion state, the metals are at the joint is heated to an metal, and that means molten state, and it is allowed to solidify. So the pressure is not applied during the welding process, and hence it is called as the non-pressure welding. Filler materials may be required during the welding. So example, arc welding, gas welding, thermite welding, then resistance welding. So we can have so many examples. And solid state welding process, that means the metal parts are heated to a plastic state and are pressed together to make a joint. Hence it is known as the pressure welding or solid state welding process, because it is not melted, right? No melting it is not going up to melting temperature. So example is diffusion bonding, for friction welding, friction stir welding, and so on, right? So now this plastic welding is normally classified into three types. One is the autogeneous process, that means welding process, right? So autogeneous process, homogeneous process, and heterogeneous process. So what is in the autogeneous process? The process is one which the filler metal is added to the joints interface, that is called as an autogeneous. So example, electric resistance welding is the best example for this autogeneous welding process. Then come for the homogeneous welding. So homogeneous process is one which the filler metal is added and is of same type of parent metal. So that is called as an homogeneous process. Then what is by heterogeneous? Heterogeneous process is one in which the filler metal but it is a different type of from the parent metal. So that is called as an heterogeneous process. So example is brazing and soldering. So these are all the important things about the welding process or classifications, right? So then come to the first type, that is called arc welding. What is meant by arc welding? Right? So arc welding process, the heat is developed by the electric arc, and the arc is produced between the between an electrode and the workpiece, right? And arc welding is the process of joining two metal pieces by melting their edges by an electric arc. So in arc welding, the electrical energy is converted to heat energy. So the arc is produced. So the electrode and the workpiece is brought near to the small minute air gap around 3 mm. Around 3 mm approximately, it tends to produce an electric arc. So how it is produced? The current is passed through the workpiece and the electrode to produce an electric arc. So the metal piece, workpiece is melted by an arc. The electrode is also melted, and hence both the workpiece becomes a single piece. So the normally around 5000 degree to 6000 degree centigrade we are getting during the welding process. So normally we are using the transformer or generator is used for the supply of electric current, and the depth of the metal is melted and deposited on the surface is called as the depth of fusion, right? So this is a schematic diagram for the arc welding. So there are so many types of equipments. We'll see one by one. Before that, an electric arc is used. Electrodes are used in this arc welding, and there may be a flux. So in that flux we have a lot of coatings, right? So it is used to prevent the reactions of the molten metal which with atmospheric air. Also it improves or removes the impurities which is present on the metal or molten metal, and forms a slag. So this slag can be deposited over the weld metal, and this slag protects the weld seam from the rapid cooling. So this slag can be removed after welding with the help of a chipping hammer, right? So while we'll see the equipments, I will explain what is in by chipping hammer, right? And the molten metal is forced out of the pool by an electric arc, and hence the small depression may be formed on the parent metal when the molten metal is piled up. This is known as the arc crater, right? And the distance between the tip of the electrode and the bottom of the crater is called the arc length. Come for the equipment. What are the equipments which is present in that? So see the diagram. Electrode holder, power supply, generator, DC power generator or AC transformer we are using. Then two cables, one for workpiece and another for electrode. Then gloves we are using, then protective shield, apron, wire brush, right? For cleaning purpose we are using this wire brush, then chipping hammer, then safety goggles, right? So these are all the important equipments which we are using. So in that electric arc welding, both AC and DC power supplies are using for producing the arc, right? So AC or DC are driven by an electric motor, often IC engines, and AC welding transformers which is used for stepping down, because there may be the available voltage is around 220 or 440 volts, but our required voltage is around 20 to 40, right? So, sorry, 20 to 90. So that is what we have to stepping down the supplied voltage, right? We come to the electrodes. What is by electrodes? So electrode is normally classified into two types. One is the consumable electrode and non-consumable electrode. Consumable electrode and another one, what is it by non-consumable electrode. See, first the consumable electrode. So consumable electrode is not only used to produce an arc between the workpiece and the electrode, but also provides the filler materials during the welding. So it is consumed during the welding, right? So these may be made up of various metals, depends upon the purpose and the chemical composition of the metals to be welded. So since it is melting during the welding process, the electrode should move towards the work to maintain the constant arc length. So this is called the consumable electrode. In this consumable electrode, we are classified into four types. One is generally two types. One is bare electrode and coated electrode. And again, this coated electrode, it is classified into three types. One is the lightly coated electrode, medium coated electrode, and heavily coated electrode. Bare electrode, right? What is on by bare electrode? So bare electrode means it do not have any coatings on the flats, right, on their surface, right? They are rarely used in welding, like wrought iron, mild steel, etc. So they must be used only with a straight polarity. When bare electrodes are used, the molten metal reacts with the atmosphere. This causes the defects in the welding. So therefore it is used in normally submerged arc welding, inert gas welding, because it is not reacted with the atmosphere directly, right? So because we are using inert gases like argon, helium, we can use, right? So what is in by lightly coated electrode? Lightly coated electrode means very light, thin, very minute millimeters, like coatings we are adding. So approximately 1 to 5% of the weight of the electrode we are using. And the main purpose of this lightly coated electrode is to increase the arc stability, called the ionizing coating. So it does not prevent any oxidation of molten metal. So the wells, due to lack of protection of oxidation reaction, have very poor mechanical properties, and hence it is used for the welding non-essential jobs. Come to the medium coated electrode. Medium coated electrode, around 1 mm, 2 mm, like thickness, up to 1 mm thickness we are using for medium coated electrode, and heavily coated electrode 1 to 3 mm thickness we are using, and it is a very good high quality coating, right? This coating and is used are composed of ionizing, oxidizing, then gas generating, slag forming, alloying, and binding materials, or it is coated, and the weight of such coating is around 15 to 30% of the electrode weight. So it is a very good electrode. And why we use this flux coating? What is the use of that? What is the purpose of that, right? See, the first one is to give the stability to the arc. Second point is to produce a gas shield around the arc and molten metal. This prevents the atmospheric reaction. So this provides the formation of slag, so it protects the welding seams from rapid cooling. So these are all the important purpose of the flux coating. And come to the second point, that is the non-consumable electrode. What is by non-consumable electrode? So non-consumable electrode means not consumed during the welding process. So metals like carbon, graphite, tungsten, which these are the examples which we are using for non-consumable electrode and which does not consume during the welding. Right, so the tungsten electrodes are used in DC as well as AC welding. So non-consumable electrodes are used in atomic hydrogen welding, TIG welding, and normally we are using in TIGging welding, tungsten inert gas welding, and hence the arc length remains constant and it is very stable. So this is called as an electrode. So this is called as a consumable, non-consumable electrode. Example, then come to the flux. Why? What is the use of flux? Right. So it is a substance that prevents formation of oxides and other contaminants in the welding or dissolves them and facilitates the removal. So it provides protective atmosphere for welding, stabilizes the arc, reduces the spattering. Right. So this is called as an so these are all the something about the arc welding. Come to the gas welding. What is the big gas welding? Gas welding is one of the types of welding process in which the edges of the metals to be welded or melted by using gas flame. So no pressure is applied during the welding except pressure gas welding, and it is the flame is produced during the welding process. The flame is produced at the tip of the torch, welding torch. See, come to the schematic diagram of the oxy acetylene flame. So not only oxy acetylene, we have other alternatives like oxy hydrogen welding, air hydrogen welding, so many. So but we are preferring oxy acetylene welding because it is very cheap, easily available. So that is what we are taking oxy acetylene welding. So the flame is produced at the tip of the torch, and welding heat is obtained by burning a mixture of oxygen and compatible gas, any gas, whatever it may be, the acetylene or hydrogen, anything, right? So propane we can add, butane we can add, right? So all these gases we can use. Mainly, commonly we are using oxyacetylene welding, right? So the gases are mixed in a proper proportion or right proportion in the welding torch head, which provides the control of the welding flame. So the flame only will melt the metal, so additional metal to be welded is supplied to the filler material. So filler material we are using here, and the flux is used during the welding to prevent the oxidation and remove the impurities, and normally it is around 2 mm to 50 mm thickness we can do with the help of this gas welding process. This is the image. So you can see all the parts like pressure regulator, pressure gauges, then cylinders like oxygen cylinder, acetylene cylinder, then torch head, mixing chamber, then flames, then nozzle, everything you can see it in the diagram, and hoses also you can see in different, we can mention in different color, right? Oxygen in black color and acetylene in red color. So normally we are getting around 3200 degree centigrade during the welding process, right? And the cost of acetylene is very very low. That is what we are preferring, that one, right? And the gases like oxygen and acetylene can be stored at high pressure in separate steel cylinders. So this acetylene is very harmful, so we should give little care to handle the gases, right? So, and another thing, it is of two types depending upon the supply of welding. right, supplied for welding. That is, one is high pressure welding system and low pressure system. So generally, if the high pressure system means zero point 0.1 to 3.5 bar, we can use it, and low pressure means 0.5 to 0.1 0.5 to 3.5 bar, we can use. That is for low pressure system, right? So this is the thing. So we can have these equations while we are getting we are doing the welding process, right? So we have a lot of things in this. Different types of flames we are getting. Different types of flames we are getting. One is the three types of flames normally we are getting. One is the neutral flame. Second one is the carburizing flame, and the third one is the oxidizing flame. What is meant by neutral flame? What is meant by neutral flame? Neutral flame means it is supplied equal amount of oxygen and acetylene, equal quantity, right? So that is called as a neutral flame. It is of two zones. One is inner cone, one sharp bright inner cone, and one bluish outer cone. So two zones are there. So what is the purpose of that zones, right? So the inner cone develops heat to melt the metal. The maximum temperature of neutral flame is obtained at the inner cone, which is about 3200 to around 3500 degrees centigrade, right? And the oxygen is supplied from the surrounding air, so it may be oxidation reaction may be taken place, and because the oxygen is it is surrounded by air, it is absorbed by the gas from the flame. So neutral flames, this is a neutral flames generally we can use to weld steel, cast iron, copper, aluminum, etc. So it has less chemical effect on welded metal, right? So and second one is the carburizing flames. Carburizing flame means carburizing flame is otherwise called as reducing flames, which is obtained by supplying more acetylene than oxygen. So it is of three types of three zones are there in flame, in this flame. So one is the sharp inner cone, white intermediate cone called feather cone, and the last one is the bluish outer cone, right? So some reactions we are getting, and the length of the intermediate cone is an indication of proportion of excess acetylene. We are giving more acetylene, so we are getting this flame. Then the last one is the oxidizing flame. Oxidizing flame means we are supplying more oxygen than acetylene, right? So to here we have two zones. One is the smaller inner cone and outer cone, right? So these are all the things whichever we want. So with the help of this oxidizing flame, we can have brass, bronze, or like we can weld, right? So these are, so depending upon the requirements, we can adjust the flame with the help of a small nozzle, right? So and gas welding techniques are there. Some techniques are there. So one is the left hand leftward or forward welding, and the second one is a rightward or backward welding. So it depends on some techniques. So the angle, the torch angle, so we can follow any one of the techniques while we are doing that, right? And the same equipments we are using, right? So first one is the we can use torches, right? Welding torch, pressure regulator, pressure gauges, hoses. So each one, and not only this, we have a goggles, gloves, then sparklighter, wire brush. We can have so many equipments, and each equipments we can select it by its characteristics, right? So for example, if you want to select a hose, right, so it has some characteristic. It should be flexible, it should be strong, desirable, non-process, and light, right? So oxygen cylinder is connected with the black hose, black color, and acetylene we can have red. You can see it in the diagram, I mean image, right? So these are all the specifications or characteristics while we are choosing the equipments, right? So this is called gas welding. So come to, before going to the MIG welding, we'll see some advantages of this gas welding. So what are the advantages of this gas welding? Temperature of the flame can be easily controlled. The amount of filler metal deposits can be controlled easily. The flame can be used for welding and cutting. All types of metal can be welded in this gas welding. So cost of equipment is very less. Then it can be used in all the factories in the field also. If you want, means we can take the setup to that exact field and we can do the work. Then maintenance cost is also less. Some limitations may be there. We'll see one or two limitations. It is not suitable for joining thick plates. Then it is a slow process. Then strength of welding is not so good as compared to arc welding. And handling and storing of gas cylinders need more care, and gas flames may be taken more time to heat up the metal and then than an electric arc. So these are all the important gas welding. See, next come to the gas metal arc welding. Gas metal arc welding. So this is an consumable electrode, and it is otherwise called as metal inert gas welding, MIG welding, metal inert gas welding. So the process is also used as an gas metal arc welding. In this arc welding, the electric arc is produced between an consumable metal electrode and the workpiece. So during this welding, then electric arc and welding zones are surrounded by an inert gas. You know very well why we are using that inert gas. Inert gas, if it is we are not using that inert gas, means what happens? Automatically it is the oxygen which is in the atmospheric air, it reacts with that metal and it is suddenly oxidized. So there may be so many defects we are getting. That is what we are using the shielding gas, right? Shielding gas, or this is, see the image, shielding gas or inert gas we are using, right? So inert gas, what inert gas you are using? Argon, helium, right? So these are all the commonly used inert gases, right? And the electrode is fed continuously through the welding head. So normally we are using the parent metal as an electrode, right? So these electrode is melted by arc and deposited over the workpiece. So it is fed manually or automatically we can do, and either we can use a DC generator or AC transformer we can use, and normally we are getting 100 to 400 amps during the but depending upon the thickness of or diameter of the wire we can use, right? And so this inert gas, right, inert gas we are using, and here also bare electrode wire plus shielding gas eliminates the slag, so no need of cleaning the slags, right? Some in this process we are doing thick plates, welding the thick plates, and it is used for welding aluminum, stainless steel, then nickel and magnesium without welding defects. Advantages, see the advantages. No flux is required, then high welding speed, then possible to weld ferrous and non-ferrous metals, then greater efficiency, cheaper process, produces high quality weld. So these are all the important things about the gas tungsten arc welding or inert gas, metal inert gas welding, MIG welding. So come to the similarly same procedure we are using for TIG welding, gas tungsten arc welding, but only the difference is we are using the non-consumable electrode. So each and every process we cannot change that tungsten electrode. So other things are very similar when compared to the metal inert gas. So these are all the advantages and disadvantages. High quality wells for suitable applications, no spatter because no filler metal through arc. Then come to the disadvantages, generally slower and more costly than consumable electrons. So we have a lot of fusion welding processes. So we have we studied 4 or 5 techniques. We studied process, but we have some other topics like electron beam welding, laser beam welding, electro slag welding, then thermite welding. So we can see in future classes, right? And come to the solid state welding process. This is so what does it mean by solid state welding process? Solid state welding process means there is no melting of metal, right? So only we are depends on temperature and pressure, right? Maybe on some time, right? Time is also a factor for this, and no filler material is added, and solid state welding process has its own way for creating an bond to the at the faying surfaces. Come to these are all the some of the important that means plastic welding, right? Some of the examples for the solid state welding process, that is diffusion bonding, friction welding, friction stir welding, and explosion welding, right? See, the first one is the diffusion bonding. So the diffusion bonding is a solid state welding process or a joining technique in which is two similar or dissimilar materials. So this is the main important thing, dissimilar materials, and are brought together under pressure at a time at temperature below the melting point of the material. So how it works? It works under the principle of Fick's law. What it states? So Fick's law states that the atoms transforms to the higher concentration regions to the lower concentration region. So that is the thing. So the atoms is diffuse, and we are getting a good joint. So it is suitable for dissimilar materials, and neat and clear welding we are getting. Then because no addition of filler materials we are added, or any electrodes we are not added, right? And no slags are formed during this process. So there is no removal of slags. So we are reducing the time. Then defect free welding processes we are getting. Then metals, alloys, ceramics, powder metallurgy products like have been joined by diffusion bonding. So no preferential failures at the joint interface. So these are all the applications like in structural and non-structural applications, right? Structural like automotive industry, then other industries, commercial, then material handling, logistics, right? So we are using these things, and aerospace equipments like automotive applications in automotive application, aerospace applications we are using. So friction welding means due to the friction we are joining the metal. So here no filler material is added, flux is no flux is added, no shielding gases is added, right? So only we are process yielding a narrow heat affected zone, HAZ, that is a heat affected zone. It can be used for joining dissimilar materials, and the application is widely used for commercial process and automation and mass production. So this is the friction welding, and these are the applications and limitations of friction welding. So generally the application is for shaft and tubular parts we are using, and limitations, some limitations may be there. Then next one is the friction stir welding. Friction stir welding means that it is also an solid state welding process in which the rotating tool is fed along with the join line between two workpieces, generating friction heat and mechanically stirred the metal to form a weld stream. So application is in aerospace application, automotive application, and shipbuilding, right? So these are all. This is the schematic diagram for friction stir welding. See the shoulder probe, right? It is rotated and it is moving, right? While we are moving, it it joins. So these are all the advantages and disadvantages for the friction stir. So how these some normally we are getting some defects, right? Cracks, cavities, solid inclusions, like some defects we are getting. How we can identify the defects by means of some inspection? What type of inspection? In olden days, we are using only destructive testing. Right, in distract we distract the metal and we can find out the fault, right, flaws, right, which is present in the welding samples or welding specimens, right? But nowadays it is not like that, because the non-destructive evaluation testing, non-destructive testings are there, right? This non-destructive testings like ultrasonic testing, radiography testing, liquid penetrant, or and magnetic particle testing, radiograph, I mean eddy current testing, and so many testings facilities are there. Without distracting the metal, without distracting the metal, we can find out this defects during the welding process. So we can identify and we can study lot of things in this in future classes. Thank you.